Trigonometry, Chapter 5, Trigonometric Identities, Section 4, More Identities, Video 6, Using Product to Sum Identities. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we derived the product to sum identities. Here you see all four of them. And you may recall, I blatantly said I do not have them memorized. I know how to derive them, and if I need to use them on the fly, I can rederive any of them. Or if I'm doing applied trigonometry somewhere, I can always look these up. In this video, we apply the product to sum identities. For example, write the expression as the sum of two functions, 2 times sine of 58 degrees times cosine of 32 degrees. The fact that this is a product and we're being asked to write it as a sum is a dead giveaway to use a product to sum identity. Answer. The structure of the expression, 2 times sine times cosine, resembles the left side of sine x cosine y equals 1/2 times sine of x plus y plus sine of x minus y. We'll worry about this missing 2 in a moment, but for now, let's let x equals 58 degrees and y equals 32 degrees all the way across the identity. Every x becomes 58 degrees, every y becomes 32 degrees. And now let's just see what happens. On the right side, we have 58 plus 32, which becomes 90 degrees. We also have 58 degrees minus 32 degrees, which is 26 degrees. Yes. So the addition and subtraction problems get evaluated. And we wanted twice this. So now we're going to bring in the 2 by multiplying both sides of this equation by 2. That'll put the 2 on the left, and the 2 times the 1/2 will cancel the 1/2 on the right. So times 2 on the left, times 2 on the right. Oh, and we have sine of 90 degrees. Well, that's just 1. We don't know sine of 26 degrees, but technically we achieved our goal on this line. It said write the expression as the sum of two functions, but it's kind of understood that if you ever end a problem with a trig function whose value you know, you should evaluate it, such as sine of 90 degrees is equal to 1. Therefore, 2 times sine of 58 degrees times cosine of 32 degrees is equal to 1 plus sine of 26 degrees. Let's try one more. Write the expression as the sum of two functions, 6 times sine of 4x times sine of 5x. Which product to sum identity does this resemble? Well, the structure of this expression, a product of sines, resembles the left side of sine of x times sine of y equals 1/2 times cosine of x minus y minus cosine of x plus y. So we're going to replace the x with 4x and the y with 5x. This x becomes a 4x, this x becomes a 4x, this y becomes a 5x, this y becomes a 5x, and our product to sum identity looks like this. Now we've created the sum and difference of two angle measures that we can simplify. This is 9x, that's negative x. And so we have sine of 4x times sine of 5x equals 1/2 times sine of 9x plus sine of negative x. But wait a second, a negative inside of a trig function can always be dealt with. Since sine is an odd function, which means opposite inputs yield opposite outputs, then sine of negative x equals negative sine of x. So we're going to take this negative out and put it in front just to make it look cleaner. Now, we need to get this 6 into the expression, so we could just multiply both sides of the equation by 6. And that'll give us 6 on the left, and 6 times 1/2 on the right will give us 3. Therefore, 6 sine of 4x sine of 5x equals 3 times sine of 9x minus sine of x. Could we distribute the 3? We could. Is there a benefit to it? I don't think so. Now you try. Pause the video and try the following. Write the expression as the sum of two functions, 5 times cosine of 3x times cosine of 2x. Pause the video, give it a try. All right, if you haven't paused the video to give it a try, here comes your fair warning. Solution in 3, 2, and 1. This is a product with cosines, so we use the cosine product identity. We replace x with 3x, y with 2x, and notice I dragged the 5 along. So the 5 is there, and then here's the identity with the 3x and the 2x substituted respectively for x's and y's. 3x minus 2x is x, 3x plus 2x is 5x. So the final answer is 5 halves times cosine of x plus cosine of 5x. Again, I don't have the product of sum identities memorized, so if you want to memorize them or have to, I wish you the best of luck.